Hey everyone, today I decided to start an organic chemistry 2 series of practicing synthesis problems of the course. It's just for practicing. So for example, we have a question here. So you can pause the video and try to do it on your own. And then you can see me do it and check if your answer is correct. And every video of this series is gonna be like, I think, maybe 8 or 10 minutes long. I'm not sure, but I'm gonna try to do it like fast relatively because it's just for practicing. It's not gonna actually explain the mechanisms of the reactions, but it's just for practicing. Okay, so you can pause the video now and try to do this first problem. Okay, now let's try doing it. So first we have a benzene which is connected to CH2O is connected to hydroxide. And usually when we have an alcohol with an acid like HBr or HCl, the acid is going to give it a hydrogen, so it's going to become a good leaving group. And then the halogen, it's going to attack after after the water leaves, it's going to attack it, so it's going to replace it. So the bromide is gonna convert the OH to Br. So the Br is gonna replace hydroxide. So we're gonna get like A is gonna be I apologize for my horrific drawing skills, but it doesn't matter, does it? So we're gonna get CH2 Br. So this is A for us. And this compound is going to react with the magnesium. Usually when we have an alkyl halide, it can react with the magnesium to synthesize the Grignard reagent. So the magnesium is going to enter here right between the CH2 and the bromide. So we're going to get, this is A, B is going to be CH2 MgBr. And then this one is going to react with CO2, and it's known that Grignard reagents are very reactive. They're really good bases, strong bases, and they react with carbonyls like ketones, aldehydes, and CO2 and water as well. So what you can think of it that way. This is CO2. So you can like consider it like you can look at the CO, either this one or this one, doesn't matter, as a carbonyl group. So this is like positive delta because it's a metal, and the CH2 is gonna, because it's minus, it's gonna attack the carbonyl carbon, and this one is gonna, like the two electrons are gonna come back to the oxygen. So we're gonna get this. This is 6 carbons, okay? So CH2, and the CH2 is connected to the carbonyl carbon and O minus, like this. So this is C. And if you add an acid, like if you add H3O plus, which is an acid, obviously it's gonna protonate the O minus. So we're gonna get carboxylic acid like this. And this is D, okay? So C was like O minus here, and this is D. And if we react the carboxylic acid with a base, obviously the base is gonna deprotonate the carboxylic acid, so we're gonna get back to C. So this is D. E is gonna be like without this hydrogen, it's gonna be O minus again, which I don't see the point of because we got back to C. Okay, so this is the first problem. Okay, this is second problem. We have hexane connected to CH2Br, and we have to get to this compound. So basically, we're adding CH2 and H2. Like we want a primary amine from alkyl halide, but we have to add one CH2 in the middle. So try to pause the video and do it on your own first. Okay, let's try doing it together. Usually when you want to add one CH2 to alkyl halide and then a primary amine, you might want to use CN, like NaCN as your nucleophile. So the first step could be simple SN2 reaction, which uses NaCN. Like the nucleophile is CN, so you can maybe add CN minus, and you can use an SN2 solvent like DMSO, and then you're gonna get, if you react this with this compound, you're gonna get, instead of the Br, you're gonna get Cn, which is nitrile group. Okay, and it is known that you can reduce a nitrile group to CH2 and H2 by using a strong reducing agent like, I call it LAH or lithium aluminum hydride, then water. Or to reduce it, you could also use hydrogenation, H2 over palladium. And then you could get, well, you can get this compound because you add here 2 hydrogens and here you add 2 hydrogens. So that's how you solve that. Okay, this is our third problem, and we have to get to this compound from this compound. So as usual, try to solve it on your own. Try to get this compound from this, and then we can solve it together. So you can pause the video, try to do it. Okay, let's try to solve it together. In this molecule, in this compound, as we can see, we have a bromide, which usually suggests that it's gonna leave because it's a good leaving group. And if we look at this final compound, there is no bromide, so we can be sure that this bromide is gonna leave. And if we look at this part of the molecule, it's this part. You can see here, we have this part here, which is this part. And then after that, we have CH2, which is this CH2. And we can see that a nitrogen, an amine, replaced the bromide. So a good way would be to start this series of reactions is by reacting this with Na(N3). The N3 is an azide, which is a very good nucleophile. So it's going to replace the bromide. So we're going to get N3 here. Okay, and azides have quite few reactions, but to get an amine from azide, we just need to reduce it by using lithium aluminum hydride, or just like the problem before, we can also use hydrogenation. So we could use aluminum hydride with water. And instead of the N3, we can get primary amine. Okay. And if we react this amine with cyclohexanone, so you should know this reaction, that if we react primary amine with ketones, we're just gonna connect this nitrogen, like we're gonna replace this oxygen with the nitrogen, and we're gonna remove the two hydrogens here. So we're gonna get amine with an I, which looks just like that. 1, 2, and this part. And then all we have to do is to reduce this double bond, which puts hydrogen here and hydrogen here. So we can finally get the compound of our choice. Okay, so this is how you do it. Okay, this is our final problem. You have to get this compound from this one, so try to do it on your own, pause the video, and then we can do it together. Okay, so as we can tell here, we have a tertiary amine, and here we have a nitro group. So obviously we need to transform this group into amine first. And to do that, we just have to reduce it with by using hydrogenation, hydrogen over palladium, or another catalyst, maybe nickel. And we can get an amine. And amines do react with alkyl halides. Usually we add iodide because it's a good leaving group. So he might attack this carbon and this group will leave. So you need two of those, 2 moles. So you could get 2 ethyl group instead of the hydrogens. And you could get your final product, which is like that. Okay, this should be part 1 for this series. I'm gonna try to make this series as long as possible because many students actually study very well for the exam, but they don't have enough problem to practice on. And I looked online, I looked it up online, and there aren't actually many free examples that you can that they can help you. So I decided to do this series. So I will try to do it as long as possible. And if you need any help, you can always add me on Skype and ask me anything. I try to help as much students as possible for free. And if you have any questions, you can also comment on this video. Good luck.